Okay, so thanks to the organizer for inviting me. And yeah, so tonight I'm gonna talk about machine learning for the 99%, and you'll see in a minute what I mean by that. Let me start from an introduction. Okay. All right. Yeah, so we're here at the conference and we're hearing about a lot of nice things. And in this introduction, I'm just gonna describe a little bit what is the state of AI these days. And so I think we all agree that all the algorithms that we see around us are improving in performances. And I'm gonna use quite a bit of material from this Stanford AI Index report that just came out. And in particular, these are some graphs that are reproduced using the data from there. And these are 4 benchmarks. The first one is ImageNet computer vision. The other 3 are either natural language processing, the superglue, and the other 2 are both together, images and text. And the red line is the human performance. So we can see here that in 3 out of 4 cases, the algorithms we have are matching the human performance in these tasks. They still seem to be lacking a little bit of common sense. This is the benchmark where AI has still a long way to go. But we can see here that there is definitely an improving trend in all four of them. And in 3 out of 4 cases, we are really getting to the point where we are similar or better than people. And then I'm sure that a lot of people at this conference have played sooner or later with Stable Diffusion these days. This is kind of the latest fashion, and it's this very nice model that was released by Stability AI. It's a generative model, and these are 5 things that I generated with that model in 5 minutes using some text prompt. You just tell the model what you want, and the model will produce it for you, and you see the level of details that you can get from it. This is quite extraordinary. So yeah, there's definitely a lot of improvements from the algorithmic point of view. At the same time, the cost of training these models is decreasing significantly. And for example, it went from this is ImageNet, the cost of training a ResNet model on ImageNet, and it went down 4x in 3x in 4 years. Now, if you're dealing with foundational models have exploded in size, and the dataset size have exploded. So the cost of training those models is actually increasing, not decreasing. But for the 99% of us which are not typically training those type of models, the cost of training has gone down very significantly. Okay, then one long-standing problem of AI in general, and especially when applied to the industry, is the shortage of talent. And this is getting better as well, because on one hand, universities have learned the lesson or are learning the lesson. And now most of the people that come out of STEM courses have taken some machine learning classes, one way or another. By the way, in this presentation, I'm going to use the terms AI and machine learning kind of interchangeably, even though they are not the same thing. But in the marketing and just in the general public, these 2 things are kind of the same. And so I'm just going to use that just to avoid the problem. Yeah, so universities have largely absorbed this idea that these days machine learning is part of any scientific background. And so you get a lot more people that have background in machine learning one way or another. You also have a lot of free and paid online courses and classes that are available to you from a lot of institutions, from universities to other commercial actors. You also have a lot of open source tools that have come out in the last few years. And then you even have these AutoML tools that are getting better and better, that are kind of targeting people that don't have a background in this type of field, but they still want to use it for a few applications. And so the talent shortage is definitely getting worked on, and is getting a lot better than it used to be. It's still there partially, but it's definitely getting better. And then investments. So investments in AI are definitely there. And last year, we got a huge peak in investment. This is the 2021. This year we are down because of the economy in general, but we are still at the level of the last few years. So the investment in the AI has gone down, but it's still at a very good level, and it is at the level where it has been in the last few years. So the investments are there and are still there. If we look at the investments by AI sector, here there is a very interesting thing to note, which is this. There is the place where there has been the most investment in startups and scale-ups is actually the infrastructure, so data management, processing, and cloud. And this is very interesting for what we're gonna see later, but keep that in mind. Okay, so summarizing, it seems like we have a very good situation, right? For the state of AI at the moment, we have modeling expertise that is good and getting better. We have the investments, we have the models, we have the hardware that I didn't talk about, but it's very well known. I mean, we have nice hardware, we have the cloud, we have a lot of compute available, and then we have the software, the open source tools, and all the tools that we're also seeing at this conference. There is a plethora of tools out there to help you with this type of workload. So everything is good, right? Not quite, unfortunately. I'm sure that you've all seen this sentence here. It's a sentence that is kind of, I mean, it's all over the net, especially for marketing material. And the percentage here is always changing for some reason. I've read anywhere from 50% to 90%. So more than X% of machine learning models never make it to production. The only authoritative source of this sentence that I found is a report from Gartner from 2020, and the number there is 50%. If you look at MLOps tools, they tend to use 80% or 90% because it makes their use case better. But even let's say that it's 50%, is still a lot, right? Half of the machine learning projects never make it to production. And you can also see it here. Now, this is taken from an O'Reilly survey. This is a survey of people that have subscribed to their AI newsletter. So these are people that are definitely aware of AI, and in many cases are using AI. So there's definitely a data skew in that direction. But even for them, there is 26% of them, they are in production, but 43% of them are still at the evaluation stage. So there's definitely a lot of lag between the ideal situation that it seems to be and the actual reality of application of machine learning in production. And so the situation that I get out of it, this is a completely made up thing. It's just a scheme that I did. It's just the plot that I did, but I think it kind of reflects the reality for what I can gather from all of these reports. So you have some measurement of machine learning maturity. This can be the number of models in production or the ROI that you're getting from these models, or whatever ML maturity metric you want to choose. And then the number of companies is the number of all companies, not just AI companies or tech companies, right? And so on one hand, you have the tech unicorns here. These are, you know, your Google, Facebook, Netflix, and so on. They definitely found very good use cases and are getting a lot of ROI out of those. Then you have a long tail of smallish situation. And I think my company, Cape Analytics, is one of these. We have several models in productions, but we're definitely not at the tech unicorn scale. And then you have a lot of people that are still at the POC level, where they are looking into machine learning and they have maybe POCs and MVPs, but they are not yet at the stage where they can extract value out of it. And then you have a ton of situations where they didn't even look into it. And so let's see why this is the case. So the first thing that I want to say is that a machine learning product is much more than a machine learning model. And this means that a model on its own, right, if you get some data, you train a model, you follow a tutorial online and you train a model, that thing is not going to give you any return of investment, right? It's not going to make any money for you. You have to build a product around it, and you have to link it to your product if you have an existing one. So a machine learning product, something that you can extract value from, is a lot more than just a machine learning model. And in my opinion, for what I can gather from my experience and all the things that I know about the field, you have these three elements that you need to take care of. The first one is the culture. The second one is the data, and the third one is the infrastructure. You need all three of this to be in a good situation. If you only have the culture, right? So you have a lot of preparation, but you don't have the data and you don't have the infrastructure, you're not going to get a lot out of this, right? You're still very much at the idea stage. If you only have the infrastructure, I don't know what you're doing, because if you only have the infrastructure but you don't have anything else, you're just overkilling it for no reason. You're probably spending a lot of money for no return. If you only have the data, you have a lot of potential, right? You're sitting on a potentially on a very interesting and very lucrative asset, which is your data, but you're not extracting any value from it. And then you have all these intersections, right? So, for example, if you're here, you have the data and you have the infrastructure to analyze that data. And this, for example, is the state of companies that have a lot of analytics, right? So you have dashboards and you have things like that that can help you make decisions, but you don't have machine learning models yet. Maybe because you don't have the culture and the people who can do that. Then you have a lot of raw material that you could extract a lot from, but you're not actually exploiting that. If you're here and you have the culture, but you don't have the infrastructure, but you don't have the data, you are in the hype stage, right? You have a lot of expectations, probably from your management, that has decided to spend time in infrastructure and hire people, but you don't have the data, right? So you cannot do much out of it. And so you have a lot of expectations, but these expectations are very, very hard to meet, right? Because you don't have the data for it. And then here, this is by far the most common, I think, situation for people that are evolving in the right direction, which is you have the culture and you have the data, you don't yet have the infrastructure. So everything is very slow. It gets a lot of effort to do. You have to do things over and over again, but you are getting somewhere, right? You are getting something out of it. So probably of the three intersections, this is the best place to be. But everybody's trying to get here, right, to the El Dorado, where you have all these three things together. And so in the rest of the talk, I'm going to look at those. But before, let's look at what makes these 1%, these tech unicorns that I talked about, successful, right? So the data, these tend to be business to customer companies, right? And this means that they are sitting on a huge amount of curated data, and this data comes from them, right, from their users. And so they have a lot of data, and this data is generated by them, so they have control over it, right? They have a lot of control over it. And so this is the first thing. They have a lot of data, and this data is of good quality, supposedly. They have the infrastructure because these tend to be large companies, right, at this stage at least. And so they have the manpower and the budget to build the infrastructure, and they have built infrastructure that have a planetary scale, right? These are, they have, they are present in many nations in the world, and all of that. They are using very big deployments on clouds and so on and so forth. And they can also afford to have a bespoke infrastructure tailored to their use case, right? So they definitely have this piece. Regarding the culture, they are able to recruit top talent, right? Because, if you are Tesla, Netflix, or Amazon, right? A lot of people want to work for you. So you are in the best situation to get the top talent. And you're also in many ways defining, and you have a seat at the table to define what the workflows and the engineering practices are in the field. And you have fine-tuned that in many years, right? And then these tend to be very tech-savvy companies, right? So also the alignment with the management, it's probably a lot easier than it is in other situations, because these are companies that are built around these things. Imagine what Netflix would be without the recommender system, right? And then the last one is you have a clear use case. There is a straightforward link between the machine learning and the bottom line, right? If you are Amazon and you can make an improvement in your algorithm that makes the recommendation 1% better, and you get a conversion rate that is 1% better, that's I don't know how many $1 billion more in revenue for the company, right? Immediately, right? So there is a very clear use case and a very clear link. Not everybody's in this situation. Actually, I would argue that very few are in this situation. And so what we can do if we are not in this situation. So let's look at the different things that I talked about. Let me check the time. So the first one is culture, right? So of course, I'm not going to be exhaustive in any of this, right? These are the things that I think are the most important, but there's each one of these could be a conference, probably not just a talk. But let's talk about culture for a minute. The first thing that I want to say is that there is clearly a disconnect between the professional training that people get in colleges and class online and all of that, and the reality of applying these things in the wild. And you can see it if you look at this, just these few things, right? So typically, if you're getting professional training, if you're doing a class, if you're doing a tutorial online, if you're doing an online class and all of that, you're probably working in monolithic notebooks or monolithic scripts, and that's about it, right? You are focusing on one thing and you're getting everything in the same place. In reality, when you're doing this for real, you are gonna get version control, libraries, component pipelines, a lot more, right? And you get essentially zero exposure to this when you are in college or you are taking these classes that are focused on the model, right? So there's clearly a disconnect here. Regarding the infrastructure, of course, I mean, you're working at a very small scale when you're doing these things. So typically you're working locally, maybe on Google Colab. That's about it, right? Most of the time. But of course, in reality, especially if you go in a fairly mature situation, you're gonna deal with the cloud, with high performance computing clusters, and definitely with remote systems one way or another. Regarding the goal, typically the goal of these things is you are learning a model technique, you're learning a tool. Your goal in this type of training is the performance metric, maybe accuracy or mean-square error or whatever. But in reality, when you're doing this for real, yeah, sure, the performance metric matters, but there are things that matters at least as much, if not more, which are you might be constrained by latency and throughput requirements, the memory footprint of your system, but also the robustness and explainability of this system, right? So when you're doing this for real and you have customers, you have to have all of these things together, right? Regarding collaboration, of course, I mean, this is mostly personal work while here you are in the team, and not only a team of peers, but you also have to deal with other teams, right? If you're a data scientist, you're going to deal with the data engineering, with the platform engineer, with the software engineer, and so on. And then the communication, right? Here, if you're lucky, you're going to write a blog post or you're going to write a report of your class or your experiment. But of course, in reality, you're going to have to talk with a lot more people than that. So there is clearly a disconnect here during the professional training. And then the other disconnect that I think is very big is that when you're doing this type of professional training, right, your workflow looks more or less like this, right? When you are dealing with models. So you are given a data set, right? Somebody handles a data set to you. You are going to explore that data. You're going to spend most of your time trying to build your model and trying to learn how to make your model better. And then you're going to spend a little bit of time at the inference stage, or maybe if you're lucky at the deployment stage, maybe you're going to do a Grad.io app or Hugging Face type of thing or something like that, right? But in reality, when you're doing this for real, right, there is a lot more to it. The first thing is that nobody's giving you a problem to solve. You have to define it for yourself. And deciding what problem to solve is a big part of the job, right? The second one is that nobody hands you a data set. If there was a data set available for your problem, most probably somebody else has already solved your problem, so you don't have a use case for it. So you're gonna have to collect and explore and clean and do this. And then definitely you're gonna have to be able to train your model, and then you will gonna have to solve the deployment problem. So to deal with the constraints that I told you about before, and then you're going to have to monitor your problem, and this is going to turn into actually a very iterative situation, right? It's not going to be a linear thing, as we will see later. And so essentially you are called to go from a model-centric approach where modeling is what takes most of your time and most of your energy, to a data-centric approach where data is going to be the definitive thing that you need to solve. And most of the time, the performance of your system is going to be determined by the data that you have, much more than the training technique that you use or the model that you use. And we'll see more about this later. So again, this is clearly a disconnect between your training and the real situation. Okay, and so let's look at it a little bit. So the first point of the real kind of situation is the define step, right? So you want to solve the right problem. And the first thing here is that I really like this quote from Jay Tukey, which is an approximate answer to the right question is worth a great deal more than a precise answer to the wrong question. And this means that you have to be in touch with your customers, with the stakeholders, and understand what is the problem that they really have, right? And this is not always easy because they might not know in the first place, right? So you are going to have to discover that with them. But then once you do that, right, you're going to try to define the problem, right, with them, and then work a solution, and then bring the solution to them, and they're going to tell you, well, actually, we need something a little different. And you're going to do this over and over again, right, until you close into the real thing. And of course, this is changing with time, right? The need of your customer can change with time. So you have to be prepared to iterate, right? The model development cycle is a cycle, it's not a linear process. Okay, and then the other thing is when you hire a data scientist has studied a lot to be able to build models. So naturally, he will want to build models, right? However, when you have a cool hammer like the data science, right, not everything is a nail, right? So sometimes you have to ask yourself, do we actually need machine learning for this, right? Because if you don't need machine learning, it's way better for you not to use machine learning, because machine learning is way more complicated and way more time consuming and expensive than a bespoke solution like maybe a SQL query or a piece of just if then else software or things like that, right? So you have to ask yourself, do you actually need ML? And this is not easy to do for people who have trained to do machine learning, right? Because that's what they want to do. But this is very, very important. Okay, and then the other disconnect that I was talking about is the production problem, right? So again, people come out of academia or of these professional courses and they never release anything to production, right? Of course. And so naturally, they don't have the mindset of this. And this is super important because these, to me, are the golden rules of a machine learning model in the wild, where you really want to extract value from it. The first one is that from the beginning, right, you have to target your production system, because if you have a very nice machine learning model that is super fancy, super nice, but you cannot put it in production, right, it's not going to make any difference for you, right? So a model is 100% useless until you put it in production. And because of this, performance is not everything. So if you have a model that is 70% accurate, but you can put it in production, that's infinitely better than a model that is 90% accurate, but you cannot put it in production, because nobody will be able to use it, right? This is obvious, but it's not so obvious if you're not looking at this from the beginning, right? And then simpler is better, right? So every time you increase the complexity of your solution, not only of your model, but everything that goes around it, that complexity is going to cost you, not only right now, but also in the future. You have to maintain it. You have to have people who maintain it. You have to explain it to somebody. It's a liability, right? Every complexity that you add is a liability that you're going to pay for. So you better be sure that it's justified, right? That it's justified in terms of performances, in terms of ROI, in terms of what you care about. And then these three things are things that are regard also the ethical AI problem that we're going to see more in detail. The first one is that it needs to be dependable, which means you have to be prepared to test your model in corner cases, and also you have to be avoiding performance drift, right? Performance drift is the process where maybe the data that your model is operating on drifts with time. Like, for example, an obvious case is shopping habits before and after COVID. Right? You built a model that was predicting shopping habits for people before COVID. Now it's going to be useless during the pandemic, right? Because people have changed completely. That's, of course, a dramatic data shift, but there are data shifts all around us that happen all the time. And also you have explainability, right? In many cases, not always, but in many cases, you need your model to be explainable in one form or another, especially when it's impacting people. And then reproducible. This reproducible it means that somebody else from your company needs to be able to take what you did, what your team did, and be able to redo it, right? Know what you did, why you did it, and how. so that the process will need to be can be reproduced, because you will have to reproduce it. As I said, machine learning development is a cycle. It's not a one-off thing ever. Okay. Last thing before the ethical AI part, another big bias that we take from our academic preparation, either in colleges or other classes, is that there again we are all focused on the model, right? And so in reality, you need to know when to stop, right? When you start a project, you need to define what is the threshold you want to meet and stop when you meet it, right? Because look at this case. This is a real, this is a Calgon competition. And you have the accuracy of the model in the blue curve, and then you have the number of teams, which is a measure of effort, right? Which is the red curve. So they got in 1 week, they got from 35% accuracy to 65% accuracy, right? In 1 week. And then in the next 3 months, they went from 65% to 68%, going from 50 teams to like 500 teams to 1,500 teams, right? So it's definitely a curve of diminishing returns, right? And so you can keep doing this forever, right? And get marginal improvements, but these improvements are not going to make any difference for your use case, right? And this also tells you that probably a person who's thriving into improving the performance of a model by 0.5%, probably this is not his sport, right? This is not the situation for a person like that. You want a person who's pragmatic, right? But okay. All right, and then this is maybe a given for somebody who's at a conference, but you have to stay up with the research, right? So the techniques that you learned 3 years ago, they are still largely relevant, but there are probably much better ones out there. And the models that you learned, there are probably much better ones out there. And so you have to stay up to date. And one obvious example is the rise of the foundational models, right? So these days you have to actually ask yourself, do I actually need to build my own model to do this, or can I use one of these foundational models or one of these pre-trained models to do what I need to do and just build the product around it, right? And of course, this wasn't there just a year ago or a year and a half ago. Okay, so I told you already about the iterative nature of this AI/ML situation, but of course, this is also a team sport, right? So now these things like data engineer, software engineer, DevOps, MLOps engineer, product manager, they could be different people, right? Or if you're in a very small situation, it might be you, right? It might be the same person wearing different hats. But you have to recognize that there are different needs and different profiles, right? And once you get to a certain scale of effort, it's not reasonable to ask the same person or the same team to be responsible for all of this, right? It's going to be impossible. So you're going to just accept, you're going to have to accept that developing machine learning product is a team sport, and you're going to have to organize your team. And so communication between the teams and all of these problems you're going to have to deal with. Okay, and then the last part that I want to talk about regarding the culture is the problem of ethical ML, ethical AI. And so this is very important, right? Because some of these models hopefully are going to have an impact on people. Otherwise, why are we building them, right? But this also means that you have to look at that impact from the beginning and make sure that the impact is what you want it to be. And so all throughout the project, you have to consider the impact that your effort is going to have on people, right? The first thing that you need to look at is you are going to need data, right? What are the biases that are in this data, right? Because the model will likely learn the biases that you have in your data. And so you have to consider from the beginning how you can counteract them and how you can deal with them. But first you have to look into them, right? You have to know what they are. And then you have to foster an environment where anybody can raise their perspective on the problem, right? And can raise flags, right? Because you might not be aware of everything that your model is going to do in your organization or for your customers. For example, a typical thing is that there might be a little bit of a disconnect between the data scientist that is developing the model and the sales team that is selling the model, right? And so you might want to, you need to foster communication between these two and make sure that they are aligned and that both sides can raise flags about the ethicality of what you're doing. And then the monitor part, this is super important. Once you have done all the work and you have deployed your model, you want to monitor it for performances and all of that we know, but also for the ethical AI side of this, which means, is the model having the impact that we wanted to have? Is the model behaving in the way that we thought it would behave in reality when used by the people who are going to be impacted by it? And so you're going to have to put in place some sort of monitoring that is going to help you assess that. I'm going to give you an example from my own company. So Cape Analytics, my own company, we do geospatial AI, which means we take aerial images like this. This is a house with the yard, and we build models for the real estate and the insurance industries. In this case, our model is a model that can detect what we call yard debris, which is trash, flammable material, used tires, anything that is in the yard that is debris. And we want to detect it because it's a liability, right? It's a fire risk. It's also has an impact on the value of the property and all of that. So the thing is, if you want to build a model like this, right, that has potentially impact on people, right? You want to be fair, right? And so, for example, one thing that you want to do is you want to collect training samples from everywhere, in this case in the United States, right? So that your model is not biased towards a specific region, right? So that your model is going to have uniform performances all over the place. But then, for example, in this case, you also want to, for example, stratify by income, right? So you want to collect positive and negative examples from different buckets of income so that your model learns to recognize the yard debris and not the income, because there is going to be correlation between the income and the amount of debris, right? But you don't want your model to rely on that. You want your model to rely on the detection of the specific debris, right? So this is one way that we, for example, that we approach this problem. We selected data from different income buckets. Now, your solution is going to be dependent on your problem. That's why you have to think about it. There is no one-size-fits-all kind of situation. But this is an example from our use case. Okay, so regarding the ethical AI, in the last few months, there have been a lot of developments that are going to be helpful in this. The first one is the European Union has put out this trustworthy AI document that is going to help you implementing trustworthy ethical AI. It goes around principle, risk, and proportional measures. And it's very nice because it gives you an assessment list. As part of the document, there is actually a very nice detailed list of things that you can look at to make sure that you are doing things right, and then you're thinking at the right questions. And so this is super useful. And also they recognize this part, which I think it's very nice, which is the idea of iteration, right? So that trustworthy AI, ethical AI is not about ticking boxes, right? Check, check, check. But it's actually to improve continuously the outcomes by involving your customers and the stakeholders. And this is where the monitoring that I was talking about comes in. Other resources are this Google Responsible AI Practices website. This is just the homepage. And they give you a lot of resources, again, to think about these problems. It's very nice and it's very, very well structured. And then the last one is, it came out just a few weeks ago from the White House, and is the blueprint for the AI Bill of Rights. And you can look at it here. So these are very nice resources to look at to kind of, start thinking about the right questions and how they apply to your own subject. Okay, that's what was the part about culture. Now let's look at the other bubble, the second bubble, which is the data. So we already said what data-centric AI is, right? The difference between model-centric and data-centric. I like to represent this in this way, which is, given a certain task which is given to you, the problem that you defined, that you have defined. So it's not given to you, you have defined it, but once you have defined it, it's there. And it has a certain intrinsic difficulty, right? Might be easy or might be hard. And so depending on the difficulty, you're going to have kind of a ground level of performance that you're going to get from your model, depending on how difficult it is. But when you want to progress from there, right, by far the things that are going to weight more in balancing the difficulty of your task is going to be the data that you have, because the data is not fixed, right? The data that you choose to select, choose to collect, choose to label, depending on what is the situation you're operating in, it's going to make a huge difference for your performance. And then secondary to that, there's going to be the model that you choose, the architecture that you choose, and all of that, and then the tuning of that. Now, I'm not saying that these two are not important. Of course, you should do your job well and do the right model and the best hyperparameters and all of that. But you will see that most of the time, what is going to have by far the largest impact on your final performance is the data that you have and the quality of the data that you have. So what makes a good data set then? First thing is your data set needs to be comprehensive, right? It needs to cover all the relevant cases. For example, let's say they were developing a solar panel model, a model that sees a picture of a house and decides whether there is a solar panel on it or not. That model is going to have to see many types of houses, many types of solar models everywhere, right? So that the surrounding and the type of the house and the type of solar model will not matter for the answer. You want to be diverse to cover all the possibilities that a certain feature can show up. This means, for example, if you have different imagery vendors or different geographical locations for us, right? You're going to want to show them to the model, right? You want your data set to be accurate. If you're doing, for example, supervised learning, you're going to have the independent feature and the label, maybe the images, the unstructured data and the label. Of course, you want to have the label as accurate as possible, so you need a strategy to measure that, and that's not an easy problem. You also want the right size, right? You don't want a data set that is too big, because it's just going to cost you a lot in terms of storage, training, time. It's going to make your iteration very slow, right? You don't want your data to be too large. Of course, you don't want it to be too small. In our domain, typically this data set size is what we need. But of course, this is going to change a lot. And then you want it to be unbiased. So you want in your model to be representing all the groups of people, for example, that are going to be affected from your model. So that again, your model is going to be insensitive to that. And you're going to want to check from that. So the idea essentially here is that you need to move from this kind of buzzword of the big data, right, to the idea of having good data. Sometimes having too much data, some part of your data is going to hurt your model instead of helping your model. So you want to have good data, not big data necessarily. Okay, and so this is our data-centric approach. Let me just go to the end of the animation just to save time. So again, iterative process, right, as I promised. So at the center, you have the data-centric, right? This is at the center. You're going to keep going back to there. And in our case, we have the bootstrap part here in yellow. You have to bootstrap at the beginning the data that you're going to start labeling, for example. Let's say that this is a supervised model. So you're going to have to start from an initial set. And you're going to use proxies to try to find your initial data set. For example, again, if you're doing solar panels, you're going to want to find locations where there is a high probability of having solar panels, and you want positive and negative. So for example, you're going to use the weather data. You're not going to get a lot of solar panels when there is no sun, for example. So you're going to use proxies to try to come out with a data set that you want to label that has good probabilities of having positives and negatives, right? So you're going to define your initial data set, and then you're going to go and label it. Once you have labeled it, you can do these two loops. The first loop is the model diagnostic loop, right? So you go here, you train it, and then you go and look and study the errors and the bias of your model against your validation set. And then once you identify places and situations where your model is not performing well, you want to find more data that is similar to those use cases, and you want to send them to the labeling and label more examples of that corner case where your model is not performing well. And this is going to give you a lot of improvement, right? And the active learning is a similar thing where instead of studying the error and the bias, you are going to start the uncertainty of the model. So you want to select the cases where your model is uncertain, however you measure that, and we will see that later. And then you're going to want to find more data where your model is uncertain and feed that, so that whatever you label next is the thing that you label that is going to give you the best delta in your model performance. And you do this over and over again until you meet the performance that you want your model to have, that you have decided beforehand, and at that point you have your final model, right? Let me give you again a case. So again, yard debris, same model as before. We identified after the first iteration a failure mode. Failure mode was you see a location like this. This is a location that has been affected by a hurricane. There are a lot of fallen trees, right? These are things that are going to be cleaned up very shortly, right, after the hurricane. And we don't want our model to detect all of these things as debris, right? But this is a very rare occurrence, right? It's a very difficult thing to find. So we want to find more examples of this so that the model learns how to deal with this. So how do we do that? And this is the idea that we are using. So here I'm going to dive in a little bit, but I hope you'll be able to follow. So you have a machine learning model here, right? This is a typical CNN. In the CNN, you have the feature extraction part, where you start from the images, you have your convolutional layers, and at some point you're going to end up with the features, right? That are also called embeddings. And then typically after that, you have a fully connected part that's going to give you your classification, right? So one thing that you can do once you have trained this at least once, right? You can take your embeddings, right? And then you can use, for example, UMAP, which is a dimensionality reduction technique that essentially maps your manifold to 2 dimensions. And then, so you're going to get these 2D projections, and you're going to, for example, plot it like this, right? Now, for example, this is a UMAP of MNIST, right? Done in this way. So MNIST is digits, right? From 0 to 9. And so you see that the classes are well clustered in different cases, but you see that there are, for example, here you have a cluster of oranges where everything else is blue, right? So you have numbers that are 1 that were recognized as 5, right? And so what you can do once you have this, right, you can say, okay, let me isolate the things where I know that the answer should be, let's say, 1, and then let me identify the things that are corner cases, right? And then what you can do is you can map unlabeled data in the same space and find other examples here that are close to these clusters of errors, and then label those, right? And so that gives you images, in this case, examples that are similar to your failure cases, right? That you can go and label and give to the model the next iteration. Okay, so this is an example of model diagnostic. And then for active learning, it's all about how you measure uncertainty, right? Active learning is you want to label examples where your model is uncertain. And so there are a lot of different techniques that you can use. The easiest one is the uncertainty sampling. For example, you can use the entropy of your softmax vector as the easiest thing to do. Many times you want to also use the epistemic uncertainty, for example, the query by committee. So you train multiple models and then you see the examples where your models disagree, right? And things like that. But you also have other examples. But the whole idea here is to find the next things to label where you're going to get the best value out of, right? Okay. And so this, to give you an idea, this is the improvement that we got by doing this exercise for the yard debris model. So by improving our data, we got an improvement in precision of 10%, an improvement of recall of 20%, an improvement of IOU, if you know what this is, by 16%. So very large improvements. To give you an idea, by using a very recent, at the time, training technique, the noisy student teacher technique, you can look it up if you want. This is a training technique that you can use at training time. We got an improvement, right? Mostly in recall of 15%, which is very good, and a little bit of an IOU. But you can see here what the difference is, right? This is the improvement by using a fancy modeling technique. This is the improvement by improving our data, right? This is way more than this, as I was telling in the beginning. Okay, that's about data. Now, the last part before I finish is the infrastructure part. So, okay, you might have seen this before, maybe not, but you can also get a glimpse of this at this conference, right? You have a lot of vendors out there because everyone recognizes the importance of infrastructure for machine learning, right? So much so that there is an insane level of investment in this field that has brought up this proliferation of tools, right? You have, I don't know, 20, 30 tools for every stage in the process, right? They can do these things. So everyone recognizes the importance of the infrastructure, or at least most people in the space. And the enemies that you are battling with the infrastructure are these three things, in my opinion. The first one is friction. So friction is what makes progressing in your model development process hard. Things take a lot of code and a lot of time, right? So the friction in your model development process. The second enemy is chaos, which means the process is unclear, is not documented well, it's not tracked, and is not reproducible. So it's a chaos, right? Everybody's doing things in a different way. They might get to a good place, but nobody knows how they got there. And especially the next team that comes up, or the next person that comes up and is called on improving that, have no idea where to start from. And most of the time needs to start from scratch, right? So collaboration is hard and onboarding new people is difficult, right? And then the last one is what I call cognitive overload, which means everyone is forced to learn 100 different tools and processes to do a lot of things. And you get to a point where it's unreasonable to ask everyone in the team to be at the same time a data scientist, machine learning engineer, data engineer, software engineer, and DevOps, right? Because nobody's going to be good at all of these things at once, right? Or even is going to be wanted to learn all of these things at once, or be interested in all these things at once. And so this is what I call cognitive overload. So this, in my opinion, are the enemies that a good infrastructure can help you tackle. But one thing that we have to start from is that your infrastructure needs to match your readiness at the stage where you are, right? So if you are a startup that is just at the seed level and needs to show a proof of concept, right? You're not going to go and use Kubernetes and Kubeflow or like, you're not going to worry about, you know, machine learning pipelines and Docker and containerization and cloud and all of that, right? You're probably going to run something on somebody's laptop if you can, or you're going to find the minimum solution that is going to take you to the place where you need to be, right? But at the same time, if you're a company with 20, 30, 50 models, this process where everybody is writing their own things in their own laptop is not going to work for you, right? So you have to match with your infrastructure, your readiness. And so despite what everybody will tell you, because of course it's their interest, MLOps alone is not the answer to all your needs, but it's definitely part of it, right? The other thing is not everyone is Google, right? Not everyone needs a planetary scale infrastructure with automatic retraining every day and you know, and all of those nice things, right? So you are responsible to look at your use case and see what are the things that you need and what are the things that you don't need now, and prepare for scaling up for the future, right? And this is super important, I think. Your infrastructure, your culture, and the team structure need to progress together, right? If you're gonna take a load of infrastructure and dump it on somebody that doesn't know what to do with it, it's not gonna turn up well, right? So if you're not bridging the gap between the cultural gap that I was talking about earlier, this is not gonna work out well. And then, okay, this is just a call to simplicity, right? So if you don't have a need for a part, don't build it, right? And there's also the whole thing about build versus buy. I'm going to give you at the end a nice resource for that. This is a debate that was on YouTube just a few days ago. It's very interesting on this perspective. Okay, so that's kind of what we want to what are the enemies that we want to combat, and what are some things to look for. You might have seen this before. These are the MLOps levels. These are a thing that the Google Cloud team has put together a few years ago, and it's kind of a standard that is used in the field. And it usually starts here, level 0, 1, and 2. I like to add another stage, because this basic engineering principle is something that you should never get rid of at any stage, even if you're building something for yourself. So the basic engineering principle is you have to have some code versioning thing. you have to have some decent software engineering practices and some documentation, right? These are basics. And if you're doing something for yourself, even if you're studying a tutorial, this is something that you should strive for yourself. Nobody should avoid these things. And then you move to the level 0 automation. Right? Level 0 automation means you have experiment tracking. When you're training something and you're trying things, you want to document what you're trying so that you know where you've been, you know what worked, you know what didn't work, and everybody else that comes after you will know that. That might be yourself in 6 months, right? So you want to track what you're doing. You want to build, if you have a team, you want to build shared libraries, right? Which means you shouldn't have 3 different people write 3 different solutions for the same problem. And you want to have testing and monitoring, right? Already at this level, because of the importance that they have across the whole workflow. Level 1 automation is one step up, which is already a good level of maturity for a certain scale, which is you're going to go from the idea that a machine learning development effort is the deliverable of machine learning development effort is a model, to the idea that the deliverable of machine learning development effort is a pipeline, right? So you have a Jira ticket, you close that Jira ticket or the Jira epic when you have a machine learning pipeline that can train your model, right? Because that's a guarantee that the person that is going to come after you or yourself in 6 months can retrain your model with very little effort, right? Maybe tweak something, maybe change the input data, maybe do these things, maybe manually, right, at this stage. Maybe you don't need yet automatic retraining and these fancy things, but at least you have an easy way to retrain, right? And then you want to have containerization and okay, manual retraining, I just said. And then level 2 automation. Level 2 automation is the level where you have a full-scale orchestration, you have maybe automatic detection of data drifts that trigger continuous retraining. You have a very developed level of automation. This is the scale of these tech unicorns most of the time, or rather, some teams in those tech unicorns, because you'll be surprised. but yeah, I mean, this is the level of maturity of a large application of AI. So of course, I mean, you're going to be somewhere in this, right? And you might be for some things at level 1, but maybe not there completely. And it's okay, right? You don't have, these are abstractions, they are useful abstractions to think about things. You don't necessarily have to match everything, right? You have to think critically about what your use case is and match that. But you are going to be somewhere in this spectrum. So I think these are good things to think about. Okay, and the very last thing that I'm going to say about infrastructure is you have to prepare for this when you are scaling up from the kind of the homemade thing to something a little bit more mature. You're going to see that you're going to have a little bit of a development and production tension, right? Because you have the development space where you have your data scientists and machine learning engineers that want to do things quickly, try a lot of things, change, adopt the nicest and latest tool. It's where you want to iterate very quickly, right? You want to have agility, freedom, quick iteration, all of that, right? That's the development mindset, right? And then you have the production mindset. The production mindset is very different in many ways, right? You want stability, you want robustness, you want documentation, you want standardization, you want a process that is understandable, transparent, repeatable, and all of that. And in many ways, these two things tend to collide. And you're going to have people on this side and people on that side that are going to have a very different mindsets, right? But both of these are involved in your process. So how do you bridge this gap, right? How do you join these two things? So it's an open problem, right? The way that we solve it is that we insert a sort of shortcut loop here where you get the capacity to do already a kind of a pre-production type of thing where you do like an experimental run or maybe an endpoint that is experimental just for some customers or things of that sort, where you give, you're gonna close the loop with the customer, right? Without necessarily going to the entire production system if you're not yet sure that what you're building is what you need to build, right? And so you're gonna build this type of shortcut that is gonna help your feedback in the model development process to be a lot faster, right? And so this is gonna give you the possibility to experiment very quickly with a lot of things, right? A lot of solutions, a lot of definitions of the problem, a lot of techniques, a lot of things. And then once you converge on something that you are confident, right, that is what you want to actually deploy, you're going to move it to this other side where it's going to be able to change a lot less, right? A lot less and a lot more slowly. But you're going to be able to guarantee to your customers in production the stability and the continuity that they need, right? Okay, so that's it. Let me just give you a very quick summary. So we talked about the three elements, right? Culture, data, and infrastructure. We need to progress together on all three fronts, and you want to match your use case. For example, business to business is typically different than business to customer for many things. And so looking at them a little bit more in detail, in the culture, we have said you have to mind the professional development gap and bridge it somehow. You have to find a process that allows you to close in the right problem to solve. You have to prepare for iteration and have a workflow that allows you to iterate. You have to focus on production from the beginning, and you have to think about ethics at all stages, right? If you go too far without thinking about this, it's going to be too late for you to correct it. Regarding the data, we have the data-centric approach that we talked about, right? The data is by far the thing that's going to give you the most impact on the performance of your system, not only in the raw performances, but also in the ethics of it, and also in the stability and in the robustness and all of that, right? And so the idea here is you get to a model as quickly as possible, a baseline, and then you use the model to decide what to do, right? To decide to help you learn what you need to do and what you need to label, and to help you verify your assumptions and all of that. And then the idea of having good data instead of just big data. So don't be a data accumulator, just produce good data. Okay, and then on the infrastructure, basic engineering principles should be everywhere. They should be omnipresent, and you should never get rid of them. But the things that you want to combat are friction, chaos, and overload, and you want to match with the infrastructure at the level of the rest of your company. Okay, these are some other resources that you can use to go deeper in some of these things. The first one is this DataCentric AI website that has a lot of resources around those ideas. The second one is this. This is just a blog post. It's just a starting point. This idea of machine learning at reasonable scale that is being kind of put together by this person, Giacomo, which is a person of the MLOps community. But there are a lot of resources there on that idea. And then this great debate here is something that I didn't have time to get in tonight. This idea of build versus buy for the infrastructure. This is a YouTube video that was put out by this community, the MLOps community, and it's a very interesting one for this topic. Okay, let me stop here and I'll take your questions.